Let's see how the semiconductor atom acquires the additional 4 electrons and becomes stable. Let's first look at this process with the help of one atom. This atom already has its 4 valence electrons and requires an additional 4 to become stable, which it shares with its neighboring atom so that every silicon atom has 8 electrons in its outermost shell. Here millions of silicon atoms are bonded together and they form a semiconductor structure which looks like this. All these atoms set up a bond with each other, which is called as a covalent bond. However, these bonds are so strong that the electron fails to break the bond at 0 Kelvin. But as the temperature increases, the electron absorbs the heat energy and it is able to break the bond. Once the bond is broken, the electron becomes free to carry the current. We get a deficiency of an electron in the structure. Hence, there is an empty space formed which can also refer to as a hole. Therefore, we consider holes to be positively charged. Electron here is negative and the empty space or hole is positive. Therefore, the immediate neighboring electron gets attracted towards this hole and fills its place, thus creating another empty space or hole. At its previous position, the process will continue in the entire structure in a random manner. So let's understand this, and the impurities that improve the conductivity of these semiconductors are called as dopants. In case of trivalent, 3 electrons of boron will form 3 bonds with silicon and in the 4th bond of silicon. There will be one empty space or hole, and as seen previously, the immediate neighboring electron will be attracted towards the hole, thus creating another empty space in its previous location. Simultaneously, the electrons of the silicon atoms attain thermal energy and keep breaking the covalent bonds at room temperature, and antimony. When we add pentavalent impurities to an intrinsic semiconductor, we observe that the phosphorus atom forms 4 bonds with 4 silicon atoms, fulfilling the needs of silicon. But even after that, there remains 1 electron which does not form any bond and remains free. Hence, unlike the previous structures, here we get free electron readily available for conduction. This electron rotates randomly around the phosphorus atom, following a circular motion. In addition to this, the breaking